Thank you all for attending. Today we are going to talk about how we introduce ArgoCD and GitOps into our company. Welcome to our talk. I'm Odyssey with ArgoCD from Git to Helm. I'm Antonio Alferez. I'm a platform engineer at the workshop.
And I'm Farah Adbib. I'm a bit nervous. And I'm a DevOps solution architect also at the workshop. The agenda for our talk is mainly this. We will start first talking about how we started using ArgoCD, some of the decisions that we took at the moment with the information that we knew. Then we will go through all the pain points we suffer from some of those decisions and what we changed until reaching the current approach that we are using to deploy our application with ArgoCD. And we will try to save some minutes for Q&A.
Right, so let's start. How we started using ArgoCD?
Well, before jumping into that, let me explain you a bit our ecosystem so you can understand better the decisions that we took. Our DevOps department is a centralized team that offers Kubernetes cluster as a service for our development teams. We manage around 55 Kubernetes clusters with their 1,600 nodes. Those Kubernetes clusters are provisioned in both public cloud and also on-prem infrastructure. Some of these Kubernetes clusters are almost independent. We have some security requirements for some of them that they need to be kind of isolated, so they only need to have access to their own artifacts. On the other hand, we work with around 350 software engineers split into different business units, and each business unit deployed their applications to some of those Kubernetes clusters. And also, it's worth to mention that our software engineers are also in charge of deploying their application into those clusters. So the processes and mechanisms we offer from our team for deployment needs to be easy to be used by them. Now we can continue, Antonio.
Right, thank you. Let me try again how we started using ArgoCD. So the first question we asked ourselves was whether to have a single ArgoCD instance to control all the classes, or to have an instance per each cluster. Well, due to security reasons and following on what Farah said about the security requirement and isolation between data centers, we went with the second option. And how did an application look like? Well, first off, the source, obviously Git, right? I mean, GitOps, Git, yeah, makes sense. So the repo URL would point to a Git repo where the Helm chart is hosted. We opted to use Git branch as a target revision. This must be noted that the naming would follow cluster-environment. And then we also decided to split the application code from the Helm chart. That was due to two main reasons. One, because theoretically they have different life cycles. And second, because we didn't want to replicate the application code in all the Git mirrors. Let me rephrase this. So because we needed that isolation between data centers, we had to set up certain Git mirrors so that each ArgoCD would point to its corresponding one. So we didn't want to replicate the application code everywhere. So we only had to replicate the Helm chart.
So yeah, now that we have our ArgoCD application defined and it's syncing from Git, we decided, we had to decide where to place the values override per each cluster and environment. So we simply decided to collocate them into the same Helm chart repository. So we have now a Helm chart repo where we have our charts and our values for each cluster. We have ArgoCD syncing from this Git repository. So for the rendering, to be able to render the manifest so they can be applied, we simply decided to use the config management plugin provided by ArgoCD. This is mainly a bunch of scripts, bash scripts in our case, where we told ArgoCD what to do with this Helm chart. So this is where comments like Helm dependency update or Helm template are defined.
So following on from what Farah said, because the rendering happened in ArgoCD itself, we had to configure both the Git repos where the Helm chart were hosted and the Helm repositories if any of those microservices needed a subchart requirement from an upstream, like, I don't know, Istio, HashiCorp, or Binami. So the ArgoCD repo configuration started looking like this.
So now let's have a deeper look to our CI/CD pipeline so you can understand how all this works together. So as we said, we have two different repositories, one for the application, another one for the Helm chart. So we have two pipelines, one to compile and build our Docker image, and another one to deploy the charts. So if we want to release a new version of the application, we need to calculate this new version, compile the application, push the Docker image into our artifact registry, and then we tag that specific commit that has generated this release with this version. Now we need to go into the Helm chart repository, update the version, calculate the version of the chart because it has different lifecycle. So now we have this 1.25.0 version, which contains the 2.10 image. We tag the repository with the version. So now whenever we want to deploy this 1.25.0 versions to any specific cluster environment, we just need to check out this commit, merge it into the cluster env branch, which is the one that ArgoCD is syncing from to be applied, and just wait for ArgoCD to tell us that our application is healthy and synced. And that's mainly it.
All right, so once we had a working solution, we shared it with some teams to gather feedback. And even though the solution worked, it solved our problems and met our requirements, we noticed that there was room for improvement. So let me go over our pain points. So because we decided to use Git as source, entailed that we had to set up those Git mirrors I mentioned before. That was infrastructure we didn't have before, so new tools to maintain. Then, and also because we had to configure the Git repos in each ArgoCD instance, implied a lot of back and forth between development teams and operations. Because we opted to separate the application code from the Helm chart, implied that we had to maintain two different repositories, two different pipelines, two different versions that theoretically were not coupled, but in reality they were. And introducing features like deploying from a branch was not as simple to introduce as we expected.
It was a nightmare.
All right. Because we decided to use Git branch as our target revision, entailed that there were a mixture of development branches and operational branches in the same repo that caused confusion among developers. And due to the override of the Helm values in the Helm chart, implied that we didn't have control over which versions were deployed into which environment, and also that, but operations like scaling a deployment entail to create or to release a new build and to deploy that everywhere to align versions. And last but not least, because the rendering happened in ArgoCD itself, led us to fail too late in the pipeline.
So yeah, we had a working approach. We were facing some issues. I mean, those issues were not that critical, right? But having all of them together was really painful. And we had always like this room of improvement. And after several tries and several changes here and there, we just decided to stop, test ourselves, and try again. So we heard about this rendered manifest pattern, which is a pattern that says mainly to render your Helm manifests and then push them into Git. And then make ArgoCD syncing from those manifests into your Git repository. So as the rendering happened before, you can fail earlier. And also with the Git diff, you can check the differences between what you have applied and what you will change. On the other hand, we were already looking into the option that ArgoCD provides, that you can use Helm as a source for your ArgoCD application. So then we just decided to get these two ideas and adapt them to our need. And this is how we end up with what we call Helm rendered manifest, which is the current solution that we use nowadays.
Right. So let me explain what did we change. So we kept our first decision of having a single ArgoCD instance per cluster. But as you might have already guessed, we made a slight change. Instead of pointing them to those Git mirrors we mentioned before, we pointed them to the artifact registry we already had, in our case Nexus, but it's irrelevant. And we also changed our application definition. Instead of pointing them to those Git mirrors, we pointed them to Nexus, as I said. We created the charts following that syntax, the name of the microservice, the cluster environment, cluster/environment, and use the target revision as the latest one. We'll go over that later. Let me emphasize on the fact that what we do now is, instead of pointing ArgoCD to some Helm charts and rendering them on the fly, let's say, we render them before on the CI/CD tool, and we just take advantage of the Helm distribution logic, let's say, so that ArgoCD doesn't have to deal with rendering, templating, values, and all of that. It just points to a Helm chart that includes exclusively already rendered manifests. It's just a plain YAML manifest with all the objects already rendered with only the values that it needs. So it's a Helm chart, yes, but like a really simple one. And you can see in our Nexus how that looks like. And
yeah. So now that we have our ArgoCD redefined, and now it's pointing to our Nexus, not to Git, we decide to review the repositories. And after dealing with these two repos, two pipelines, two different versions, not aware about which real version of the application we are deploying, we just decided to unify them. So now we have a single Git repository where we have our application code, our Docker file, and also our Helm charts. On the other hand, we also reviewed where we were placing the values override per each cluster environment. And we decided to place them outside the repository. Why? Because we didn't want to go through the whole pipeline just to upgrade the number of replicas or updating the sources. So that's why we defined a separated Git repository. We have one per each cluster where we define the override for the specific application, the environment, and the values. So, and this repository will be used on the CD part. So whenever, right before templating, we get also this repo, we generate the manifests, and then we push them. So we don't need to go through the whole pipeline. We will dig deeper while reviewing the CI/CD pipeline afterwards. So yeah, now the Helm rendering is happening on the CI/CD tool, so we don't need to use the config management feature that ArgoCD provided. And also, we don't need to configure all these Git repositories and all these Helm repositories into ArgoCD as we used to do before. So now there is no repo at all. So yeah, our new and bright CD pipeline.
Right, let's start from the basics, versioning, because we joined them together again, the application code and the Helm chart. We took advantage of that and used the same version for both of them. We went with Semver because it's Helm compatible. And the major version of it is up to the developers, completely up to them to decide. Then the minor version is the one that specifies the release or the build so that it increases incrementally. It increases by 1 with each build. For instance, 2.1, 2.2, 3.3. And then the only difference between Docker and Helm is that the Docker tag includes a 0 as the revision part. That's only for consistency. We don't use it. And then in the Helm chart, we append as build metadata the commit hash of that external repository Farah mentioned. And also that, but the revision part increments with every deployment of that major minor version. Why do we do this? Because thanks to this, we can track what happened and what was deployed at a certain point at any given cluster environment. Do you remember how we mentioned that introducing deployments from a branch was kind of a nightmare in the old approach? Let's call it that way. Now, it's as easy as appending the branch ticket or ticket or string to both the Docker tag and the Helm chart version. And that's it. It works.
And this is our new pipeline. Now, as we only have one repository, we only have one pipeline. And how does this work? So imagine that we made a change in our application, and we want to release it and deploy it. So we calculate this new version. We compile the application. I mean, the pipeline may also have tests and other stages, but this is just a high-level summary. We build the Docker image. We push it to our registry. We Helm package the charts with the same version also. And we tag the specific commit into this repository, so we know which is the specific commit that has generated this release. Now, whenever we want to deploy this 2.10, that 0 application to in a cluster environment, we get the Helm package of that version. We get this external Helm value. And we just executed a Helm template with the values override that we have defined. We also provide a manifest diff between the generated, just so developers can check what has been changed. And we Helm package those rendered manifests again. So with the name of my application, the name of the cluster where I want them to be deployed, and the environment for that cluster, the version. From here, I can know exactly that this is the 2.10 is the application version that I'm also deploying. And we add the commit hash of this Helm external values, so I'm always able to know with which specific commit this manifest has been generated. So then we push them to our registry, and as ArgoCD is syncing from our registry, waiting for the latest available version of that specific application cluster environment, so we check the status. So whenever ArgoCD is green, then we also tag that commit with the cluster environment. This is to be more GitOps, right? Because I want to be able to go to my Git and directly find which version I have in a specific cluster environment. Because we have some kind of applications that we deploy to all these 55 clusters, and this is the easy way to be GitOps. And also we use Git notes to store more information that we use for other cases that I may not have enough time to explain them all here, but yeah. So now, whenever I want to change the number of replicas, I just need to commit into this external Helm value and trigger the CD pipeline. This will generate a new version with the revision pumped up. Then we add this commit hash of this new commit. And simply that's it. So the Git nodes that I've just mentioned, this is mainly like a kind of node that you can attach to a specific commit. So we add to the commit information that we consider brings value. This is mainly because I'm really picky and I really want it to be really, really GitOps. So we have them for auditing purpose.
All right, so let's go over the takeaways of our decision path and what we changed over time. Because we first used Git as a source, implied that we had to set up those Git mirrors. Again, as we said, that was infrastructure we didn't have before. When we switched to Helm, we didn't need that anymore. We already had that artifact registry. Then, because we moved the rendering logic from the ArgoCD itself to our CI/CD tool, we effectively shifted left that logic so that the feedback loop is just way quicker. Our pipeline scripts were first based on Git commands, and over time, they started looking more complex and complex. Whereas now we have Helm commands that are just, I don't know, for us at least, they are just simpler. Now that we introduce that external Helm value repo, operational changes like scaling our deployment are just way quicker. And introducing new features like branch deployments are, again, simpler.
And yeah, so as a summary, our main lessons while taking decisions when you're introducing something new into your company is that your ecosystem really matters.
Even though the industry and the community can have same guidelines and same defaults, let's say, they may not apply to you. You have your own requirements, your own ecosystem, and you must take that into account.
And your development teams matters.
Don't forget, like we partially did, that your developer experience is your end goal, is your real client.
And the most important one is that you matter.
If you introduce new infrastructure, like we did with Git, those Git mirrors, those are more management tasks. If you introduce your team along different tasks along the pipeline, that means back and forth and a slower workflow. And even though you may have spent time on a solution, don't fall into the sunk cost fallacy. If it doesn't work or if it doesn't feel natural, just think it through and, I don't know, think about it and redesign it. If it, I don't know, just think about it.
So, yeah, that was mainly it. For sure, there are a lot of other decisions that we took during this process and Odyssey. It's like we use also the app of apps. We use other features like for the namespaces stuff and so on.
Role-based access, application in any namespace. There's a lot of details we haven't covered, but yeah. We'll be around today and tomorrow. So if you have any questions, we will be, obviously, do not hesitate to ask at any point in time.